欢迎我们的讲师 Paipo。
Okay, hello guys. It's my first time speaking at the conference, so if I look really nervous, bear with me. I'm actually Taiwanese, and the reason why I use English is because my manager comes all the way from Japan, so I kind of have to use English. Okay, so first of all, I would like to ask you, how many of you are creating a marketplace app? Please raise your hand. Any of you? No? Okay, at least we have one. And I'd like to ask you, is your marketplace app has a transaction page? No? All right. Okay, so first of all, I would like to put more emphasis on the importance of this transaction page. And first of all, as a marketplace app, and it allows user to do buying and selling inside application. So the ultimate goal is to let the user to complete a transaction. And the reason is that's how our business can make money, right? If you fail at your transaction page, your business cannot get any money out of your users. And third of all, normally this transaction page will involve a lot of business logic, because you may cooperate with your delivery companies, some third-party companies, and you may sell different types of your items. And those different items may need different customized user flow. So that's what makes this transaction page complicated. So today I would like to share how our company doing re-architecture on this transaction page, and at the same time sleep well. And I haven't introduced myself. My name is Paipo. Right now I'm working in Japan as a front-end engineer. I've been to Japan for 3 years. And I work at a company called Mercari. And we just went IPO last July. Right now we are kind of biggest C2C marketplace in Japan. And that's what we are doing. We are a C2C marketplace app, as I mentioned before, allow users to enjoy buying and selling. And here are our page look like. We also have our transaction page. Although we only have one page, but it involves a lot of business logic, as I mentioned before. And here is our basic structure. First of all, seller can list their items inside the listing page, which is implemented using native code on Android and iOS. And after the transaction is made, the user can navigate to the transaction page, which is implemented using WebView. And the reason why we use WebView is we have so many business logic inside this page, and we want to release fast. So we don't want to go through those process for iOS and Android, so that's why we use WebView. And we have a problem. I believe every marketplace app which has a transaction page has their own unique problem. And for our problem, first of all, of course, we have buyer and seller. And we also sell different types of items inside our application. And not only some usual stuff like clothes or shoes or pants, we also sell big furniture, smartphones, or cars. So imagine if you want to buy a car online within a marketplace app, you have to exchange some documents like car certificates or some other documents you have to exchange with your seller. And we try to facilitate those user flow inside our application, inside this transaction page. And after transaction is made, we also have different transaction statuses from payment, delivery, review to complete. So it's all inside transaction page as well. And last but not least, we have different delivery methods. For example, we cooperate with like post office, convenience store, or some third-party companies in Japan. And each different partners, they want to implement their customized user flow inside transaction page as well. And other than these different factors, we also have some special flow like cancel request flow. What if after the buyer buys something, they want to return? And those kind of cancel flow also implemented inside transaction page. So at the end, we have different roles, buyer and seller. We have different item types. We have different transaction statuses. we also have different delivery methods. And it's all inside this transaction page, which make us a 4-factor problem we have to deal with. And what makes it even worse is one day your PM will go to you and say, how about let's do re-architecture? You just need to make your page totally the same as the previous one. And with those fancy technology like React or Vue or Angular, those kind of stuff. So it will make your life miserable, but you still have to do it, right? Because you got paid from your company. And so that's why today I'd like to share the whole process, how we handle re-architecture project. So first of all, you have to analyze the current problem of your code base. You shouldn't do anything further before you find the existing problem. And here are our original code stack. We use HTML, CSS, and JavaScript, of course. And we use jQuery as our utility library. And we use Knockout as our view model to handle our data flow. And those can be cool if you use it right. So first of all, in order to analyze our current problem, we check our lines of code of our file structure. And as you can see here, for HTML, considering we have so many different complicated logic, we only have five files. And one of them is more than 1,500 lines of code. And as for JavaScript, one file is even more than 2,500 lines of code. And which makes our code is really hard to maintain and read. And also if you want to do some optimization like code splitting, and these cannot let you do that. And if you want to give it a cool name of this kind of application, you can call it single file application. So yeah, it can be cool. Okay, let's get into check some code. First of all, let's see some display logic. As I mentioned, we have a 4-factor problem, right? And how we handle it? First of all, we check different transaction statuses and delivery methods. And then we check the different rows to see if it's either buyer or seller. And then we check the payment methods. It's a body part of this page. So we have more and more logic inside this big page, big file. And those deeply nested logic makes this logic is really hard to read and change. So imagine if you want to add a new feature or remove the existing feature. It's really hard for you to pinpoint the right place where you have to add the logic. And so that's why I want to improve. That's our first problem. Our second problem, is mixed logic without proper layers. And last but not least, we have code like this. And when you see this kind of code, you may ask, why it has set time out? I guess it's because of reasons. And why it has window.location.reload? Okay, interesting. So we have many mysterious code inside our application without like proper comments or proper explanation to tell us what's the intention under the hood. So other than those problems I mentioned, we also have other performance issues that we want to improve. And the next step of your re-architecture project is you have to set the targets. In our case, first of all, of course, we want to turn those spaghetti code into more organized layers. And second of all, we want to make sure our new code base is easier to modify. And by modify, I mean it's easier to add new features and remove existing features. At the end, we want to make sure we can sleep well along the way of re-architecture project. After we set our target, the next step you have to make decision is, are you going to start from scratch or you want to migrate page by page? And I would say both ways can work. It comes with pros and cons. And I've been working with re-architecture project in different companies, and I've been using these two strategies. And as for start from scratch, of course, you will involve less complexity, because you don't have to deal with the legacy code base, and it's easier for you to make the right decision. But of course, it may involve longer time because you have to design everything from scratch, from your Divi schema, your user flow, your design, everything. And as for migrate page by page, it may involve less risk because you get feedback from your customer much earlier. Because you keep releasing your page, and if something goes wrong, you can just revert the small part of your system. But you have to struggle with legacy code, because right now you are maintaining 2 versions of your code base at the same time. And what's happening in my previous company is we start from scratch, and we design. It took us around 1 year to design, and the other 1 year to implement. And after we release the new system, replace the new system, and we received so many complaints for our customers. And at the end, after 1 month, we roll back the whole system. So that's how risk comes from. And in our case, because it's a transaction page, we don't want to involve too many risks. So that's why we decide to migrate page by page. And after you decide your migration strategy, the next step is you have to find the divisible unit. And what does it even mean? So as I mentioned, we want to adopt migrate page by page strategies, right? So you have to define what does it mean by page. Normally it's split by different URLs or different pages. Like if you have home page, you have product page, you have detail page, and you can re-architecture each page one by one, piece by piece. And in our case, we are using WebView. We only have 1 entry point, which shares the same URL, and which make us, we cannot just migrate page by page by using different URL or pages. We have to decide by different state. And here are some other criteria we use to decide the divisible unit. First of all, of course, this unit can let your team members work in parallel. You don't want to make change on the same file, and you have to resolve the conflicts all the time, which involve a lot of overhead. And the next step is you want to make sure after you decide the divisible unit, it's easier to add the new unit and remove the existing unit. And the next step, we want to put more emphasis on how you connect with your business. We want to make sure those divisible units can be a meaningful business unit as well. Because most of the time when developers decide the divisible unit, it only makes sense from programmer's perspective. It doesn't make any sense for business people. And why it's not good is because after you finish 1 unit, maybe it's still not releasable because it just doesn't make sense for your business, for business side. So that's why I want to put more emphasis on this. And at the end, we want to make sure each unit can be mapped to a code splitting target or an end-to-end test target. As I mentioned, we have 4 factors: role, item types, delivery methods, and transaction status. And those can be a potential candidates for your divisible unit. And let's go through one by one. First of all, if you split your code by different roles, which has buyer and seller, the problem with this is we only have 2 roles. And underneath, they have many different transactions or delivery methods. So the scope is too big. It takes too much time to implement. As for transaction status, if you split your divisible unit by transaction status, for example, payment, delivery, review, and done. And the problem with this is each transaction status is not really a whole business flow. So after we finish implement 1 unit, maybe it doesn't make sense to release. And also, comparing with delivery methods and item types, transaction status barely change, which means we only have 4 different transaction status, like nothing more. As for delivery methods and item types, we keep adding new item types or adding new delivery methods because we cooperate with different third-party companies to improve our delivery flow. So in this case, if you split by transaction status and you want to add new delivery methods, you have to make change to every single folders. So make us hard to modify. So that's why at the end we choose delivery methods and item types to be our divisible unit. Because each different delivery methods or item types, it contains buyer and seller and the whole business flow. So if you want to add a new delivery method, you can just add the new folders and have a buyer and a seller underneath, have different transaction status. And as I mentioned, it can also help on your code splitting. And this is a code from a Webpack that you can dynamically import module. But most of the time, the most difficult part is it's not writing this kind of code. It's how do you make decisions on those divisible units. But if you find it, it's much easier. It's like natural to put that as a key. In our case, we just put item types and delivery methods as our key to do our code splitting. And underneath, we can do even more. We can split by buyer and seller. So imagine if you are a buyer and with the smartphone, buying a smartphone in our application, when you go into transaction page, you will only receive the minimal necessary bundle from our server. And after we find our divisible unit, the next step is how do we make peace with our old code base? And in our case, it's not that hard, because we have one single entry point. We have a listing page. After transaction is made, we can go to open transaction page. And we will call the API to get an item type and different delivery methods. And we only need to check if this transaction type has already been re-architectured or not. If it's not, we will just replace window.location.replace to go to the old URL of our old code base. And if it's already re-architectured, we will stay at current code base. That's how we make peace with old code base. There's no special magic here. And finally, we can start writing some code. And here are our new architecture. We use React, Redux, and Redux Saga. And if you still remember our original issues, we have deeply nested logic and make us really hard to read and make change. However, even with using the new technologies like React, and after re-architecture, you can still making code like this. It's super nested as well. And you don't feel happy after re-architecture. You can still mess up. So how can we improve this? We think it's all about layers. Programming is all about layers, right? And if you are coming from React world, React ecosystem, you may split your logic like this. You have a presentational components, you have smart containers on the top, you have another side, you have some middleware to handle side effect like Redux Saga or Redux Thunk. Or you can put one extra layer in between, which is just another presentational layer. In our case, we call it blueprint layer. And what does this do is, this blueprint layer, the purpose is when the developer is seeing this file, he can know how the page should look like. For example, if we have a transaction status, which is a payment, under payment status, and by seeing this file, he or she can know we have a notification on the top. And then we have some side links. And we have some main body, which is selecting different payment methods. So that's why we call it blueprint layer. Without checking the details of what's happening underneath, we already know how the page should look like. And the next layer is smart containers. And we don't do anything special than other people. Like we have map state to props to get the state from our global store. And here you can use some selectors to caching your complicated calculation. And if you have some side effect, and it will be handled by Redux Saga. And by side effect here, I mean if you want to consume the API or you want to do some input and output, and this Redux Saga function will handle this for you. And other than this, we have smart containers to handle the branching logic for us. So imagine if we have a common box, we have different type of common box. Instead of putting this kind of branching logic underneath in the presentational components, we try to isolate those logic here inside these smart containers. I think it's similar as what most people will do, I guess. And underneath, we have some presentational components, which just export different types of common box for us. And you will wrap some different state and props for these components. And the next thing we want to put more thoughts on is side effect. The problem with side effect is normally it's not really understood by those PMs because it's kind of technical terms. And when you read the spec from your PMs, it depends on how you recognize those statements, and you will find those side effects inside the spec. So the flow is first you will read the spec, and then you may recognize those different side effects like coding API and show like different dialogue inside our application. At the end, you will compose those side effects together in order to fulfill this spec, business spec. And as I mentioned, we handle those side effects with Saga and inside our smart containers. But most of the time, we find those business logic is kind of mixed with our display logic. It's scattered everywhere. And our business spec are lost in our code base, which means when developer looking into the code base, he cannot imagine how the original business spec should look like. So we think as a developer, how can we be more connected with our business spec? That's what we are trying to solve. So first of all, we separate into two different kinds of logic. One is called display logic. The other is called business logic. What's the difference? This is an example of display logic. Imagine if there's a comment box. You may receive a markup from your PMs inside your spec and have some statements. For example, I want a comment box with a text area and a send button. And if no message inside, the button should be disabled. And the message should be less than 150 characters. And if you notice, I use a bullet point here. It means you can change the orders, and it doesn't make your spec change the meaning. How about clicking this button? And it will bring you another piece of spec, which may look like this. And we call it business spec, business logic. It's a send message flow. And it will describe like this. First of all, I'll type in the message in the comment box. And second, a dialog box will show up confirming if I want to send a message or not. And third, after we click the confirm button, we want this message to be sent and stored somewhere. If everything goes right, we want to see all the message. If something goes wrong, we expect to see some error dialog. So we use number point here because inherently it's step by step. It's more imperative. So we conclude business logic is inherently more imperative than display logic. And for display logic, we think it's perfectly matched to declarative styles. So you can put your layers, use your presentational components and smart containers to handle those display logic. And as for Redux Saga, instead of letting them only handle the side effect, we want to be more well-defined, the Redux Saga to handle the whole business logic for us. And even more, we try to separate our business logic with display logic. So the idea is we try to separate the imperative logic from declarative. Although people say writing declarative code is good, but we think it's more like a relative concept. You can always be more declarative. But speaking of business logic, inherently, it's more natural to call it imperative compared with those markup or display logic. So how we handle it? If you still remember this spec, we have 1, 2, 3, 4, 5, 4 different statements in our business spec. And we kind of isolate every single step with our Saga function. So the first statement is we will type in a message in a comment box. And what we are doing is we just get the message from the payload. And second, a dialog box will show up, confirming if you want to send a message or not. And here we just use Redux Saga to cause some side effect, and that the native side to handle the rest for us. And the third step is click confirm button, message will be sent and stored somewhere. And here we just cause another side effect, that the API to handle the rest for us. And if something goes wrong, we will expect to see some error message. It's the same, we cause another side effect, and that the native side to handle the alert for us. because we are kind of a hybrid app. We have native side, we have our web view side. At the end, if everything goes well, I expect to see all the message on the page. And the same cause another side effect and call the API. So at the end, the whole spec is persist in one Saga function. And when developer implement this business logic, he can understand the whole flow of our business spec. That's what we are trying to do, what we are trying to improve. At the end, we have one business spec. It can be mapped to one Saga function. And it can also map to one test, which I'll get into more detail later. And last but not least, I would like to share how we apply different testing strategies on different layers. So as I mentioned, we have 4 different layers. And for each layer, we handle our testing strategies using different tools, from Saga test to story shots. And on top of that, we use Cypress to handle end-to-end tests for us. So for story shots, it's easier to use that to test the display logic, as I mentioned. If you have a markup like this, and if you use Storybook, it's really easy to apply the story shots. You just need an add-on. And once you run the jest, it will generate a snapshot for you and compare. But the problem with story shot is it's kind of hard to review. So when you see a diff like this, you don't know if these introduce some bugs or not. But it's easy to write, so we still keep it. And as for the business logic, if you still remember this spec, what we are trying to do is we still try to keep the single source of truth inside our test. The same as our Saga function. We have each statement perfectly mapped to a code snippet. So the first statement will be maybe typing the message in the comment box. And in our test, we just need to mark the data of message. And second, a dialog box will show up confirming if I want to send a message or not. And unlike the Saga function, here we just expect, we only need to expect these side effects will be caused by our function. So we are kind of validate this business spec in different angles. And if you have more statements, you can put it here. And the problem with Saga test is it's also really hard to maintain, because when you review code like this, the Redux Saga is based on generator functions, which based on the iterative patterns. So when you review this kind of code, you have to deal with .next, and you have to clone different generators in order to handle your branching logic. So that's why we're trying to move our test to our end-to-end test. We start to write more end-to-end tests and decrease the time to writing Saga test. And for end-to-end test with Cypress, it covers the best part of both worlds. You can use that to test the display logic. For example, you can assume like some title should be visible, or some buttons should be shown on the page. And you can also use that to test the business logic. And the same, we try to keep the single source of truth of our business spec inside our end-to-end test. So you can still perfectly map each statement of your business spec to the code itself. And comparing with Saga test, end-to-end test with Cypress is much easier to write and review, because its API is more natural comparing with Saga test generator functions. And at the end, our small dreams is once we receive a story from our PMs, we try to split into different acceptance criteria by PM, QA engineers together. So we own a single piece of source of truth. And those can be mapped to the E2E test. In the future, maybe those E2E tests can be even written by PM or QAs with some domain-specific language. And then we can use those E2E tests to generate tasks. And all the developers only need to tag those tasks and to fulfill the contract. That's our small dreams. And at the end, I want to do some recap of the whole re-architecture process of our company. First of all, you have to identify the current issues. You shouldn't do anything further before you find existing issues. And second of all, you better model your problem with the right code structure. Because in our case, we have to find the divisible unit based on the 4-factor problem. When we have different state, we have to find what's the top layer of our folders. And the next suggestion is you better keep the single source of truth for your spec. In our case, we use acceptance criteria to be our single source of truth. And you should find your own as well. And programming is all about layers. Try to separate your code into different layers. And at the end, apply different testing strategies for your different layers. And last but not least, try not to make your re-architecture project another re-architecture project a few years later. Because it happens everywhere, every company. And as a professional engineer, try not to make it happen. And that's pretty much it. Thank you.
好的，请问在场的各位有没有什么问题要问我们的Paipo？好的，那再次以热烈的掌声来谢谢我们的Paipo。然后也是我们